So the main purpose of this lecture is trying to fully understand an expression such as p big X equal to small x, where x is a random variable. The setup of this lecture is that we have an experiment. We have a sample space S, and the experiment will pick one of the elements in S. We have events or subsets of S. We have a probability measure P, assigning probabilities to each of these events in a fashion consistent with the probability laws. And on all of this, we have defined a random variable x, which is simply a function from the sample space to the real numbers. So here's a particular example. We have a sample space S consisting of 4 Greek characters, alpha, beta, gamma, and theta. To make this example simple, we assume that each outcome is equally likely, which is not necessary. We consider all 16 possible events. There are 16 possible events. Since we have 4 possible outcomes and 2 to the 4 is 16. I have defined a random variable, which I call x. This is a function from S, that is from this set here, onto R, and it maps in the following way. It maps the alpha to 1, the beta to 2, the gamma to 3, and the theta to 3 as well. The first thing we will consider is this notation, x equal to x as a set. This symbol here refers to our random variable x. This lowercase x refers to an arbitrary real number. So specific examples of this notation could be something like capital X equal to 1 or capital X equal to minus 10 or whatever. You can replace this lowercase x with an arbitrary real number. So exactly then, what is this set? Well, this general notation, which we pronounce as the collection where the random variable x takes the value x, this expression is simply an event. And remember, an event was a subset of the sample space. So it's a subset of this S right here. And this subset contains all outcome that the random variable x will map into the real number lowercase x. Exactly what event this is depends on the lowercase x. For example, this event is the collection of all outcome that the random variable x will map to 1. Well, it only maps one symbol to 1, namely alpha. So this is exactly the same thing as alpha. In the same way, the event capital X equal to 3, well, that's the event consisting of both gamma and theta, simply because X will map both gamma to 3 as well as theta to 3. With this definition, we can fully define what we mean by, for example, the symbol px equal to 1. And what we mean is that this is the probability of an event A defined as the collection consisting of only alpha. If each outcome is equally likely and we have 4 possible outcomes, that means that this probability x equal to 1, which is probability of A, which is 1 over 4 in the case of all outcomes being equally likely. Similarly, what we mean by px equal to 3 is simply the probability of the event consisting of all outcomes that x will map to 3. And that was, as we concluded, gamma and theta. If the outcomes are equally likely, this will be 2 over 4 or 1/2. If we consider something px equal to 4, then, well, briefly going back to our random variable x, we see that it doesn't map any element to 4. 4 is not in the range of the random variable x. So that is simply the same as the probability of the empty set, which in turn is equal to 0. We can extend this idea to probabilities of intervals. That means that, for example, something like x less than equal to 2, this will be an event as well. In this case, it will consist of all outcome that x will map to a number which is 2 or less. Going back to the random variable x, we see that alpha is in there, it's mapped to a number 2 or less, and we see that beta is in there, but gamma and theta is not. So this is exactly the same as alpha and beta. So using the same principle, this symbol here, probability x less than equal to 2, simply means the probability of this event, alpha and beta. Assuming that the outcomes are equally likely, this is again 1/2. As a final example, we can also do events where the random variable is bounded from below as well as from above. So I can do something like 1 less than equal to x less than 3. To figure out what this event is, just go back and see which outcome is mapped into this interval. Greater than equal to 1, less than 3, and going back to the random variable x, we see that that includes alpha, beta, but not gamma and theta, because we want it to be less than 3. So this is again alpha and beta. We also write probability 1 less than equal to x less than 3 is then the probability of alpha beta, which is 1/2.